All right. I want you closer. Thanks. All right. Today we're going to talk about notes on translations of sine and cosine functions. Today we're talking about phase shift. This is basically just a right or left movement. And we've talked about this before. If we had a parabola and it shifted 2 units to the left, well, we would write that like this. Let's actually do a quick preview. If I had this function, the computer is very slow today. If I had this function, y equals that is a parabola, right? A parabola started at 0, 0. Our vertex was at 0, 0. Oh my goodness. Okay, but then my vertex shifted where? What did the plus 2 do to my vertex? It shifted it up 2. Alright, so now we're over here, up 2, 1, 2. And the minus 5 took me where? Right or left?
Right.
Good, it's the opposite. So it looks like, oh, we're going left. No, we're really going right. So we moved right 5. So I would be at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 2. Okay, so this was my right or left movement, and what's on the inside, it's the opposite. This was my up or down movement. That is what we're learning about today, but we're doing it with sine and cosine functions. Okay, here we go. Alright. So, a phase shift, this is important, go ahead and write those words down. A phase shift is a horizontal translation or shift of a trigonometric function. So far we talked about A and B. Today we're going to talk about C. This was kind of like our H in the other transformations. We're going to talk about H and K. We don't want saying C is not equal to 0, so that means a phase shift exists. Some shift happened. So an example would be y equals 5 sine of 3 theta minus pi over 2. My A in this case, what is the amplitude of this function? 5. So this right here, for Sarah, for you who weren't here yesterday, this is our amplitude. Whether it's positive or negative, we're going to do the absolute value. So our amplitude is 5. What is our B value? So this is our A, it's our amplitude. Our B is 3. And that's going to help us determine our period. To find our period, what's that formula that we use? 2 pi over B. So we're going to say 2 pi divided by B. Well, B is 3, so 2 pi over 3 would be our period. That's our amplitude, that's our period. Okay so far? That's just a quick review of what we did the other day. So now we have a phase shift. And this phase shift is taking us either right or left. You guys need to decide which way it went. So our phase shift took me where? Pi over 2 units where? To the right. Yeah, it's the opposite of whatever we see there. So pi over 2 to the right. Are we okay with that? Alright, now sometimes, notice how this 3, this B, is factored out. Sometimes it's not factored out for us and we have to factor it out. So I'm going to do a quick side note and talk about how to factor it out. Oh my goodness. Okay, here we go. Let's say I had something like this. The sine of 4 theta plus pi. 4 theta plus pi. That 4 is my B, but in order to talk about it as B and have our phase shift correct, we have to factor it out. How am I going to factor a 4 out of both of those? 4 times something, and it gets me back to that. So how do I get a 4 out of there if there's no 4? Here I just say, oh, 4 times what? 4 times theta. Aha. So it'd be 1/4. Alright, a way that I thought about it, maybe you have another way of thinking about it. I thought, well, I need a 4 there, and there is no 4 there. Let's put a 4 there. times 4. But I can't just go times 4 on top. I have to also multiply by 4 on the bottom. So really I'm multiplying by a factor of 1. So now there is a 4 there. I can factor the 4 out, and what remains? Theta plus pi over 4. Does that make sense? If I multiply this back in, I get 4 theta plus pi. Okay? So this would be our B, and this would be our phase shift. Alright. So that's a quick introduction to what phase shift is. Now, the next one has a bunch of words. You don't have to write all of these words down, but Dimitri, we're not looking at our calculator yet. I'm sorry, so I'm going to ask you to put that down. Okay, so finding the phase shift and the period of a sine and cosine function. Sine and cosine have a period of 2 pi. Hopefully we're knowing that by now. We got that? From 0 to 2 pi, we already know that, right? That is one normal period with no transformations happening. So our normal period starts from 0 and goes to 2 pi. So I'd like everyone to actually write that down. From 0 to 2 pi, our theta is occurring in between there. Our angles occur from 0 to 2 pi. That's one full period. So there was a phase shift of sine. What was the phase shift here? We moved how many units where? We moved left. How many units? Pi units. Good. So we could actually think about this. From 0 to 2 pi, if we move left pi units here and there, it'll get us to where our new start and our new stop will be. Yes? I would like you to write pi because pi is exact and 3.14 is an approximation of pi. Okay. So, what we're going to do, in place of theta, right here, we're going to plug in our new theta plus pi. And this will tell us where we're going, where we start and where we stop. So, we're going to write down 0 is less than or equal to, instead of theta, I'm going to write theta plus pi. Now I want to solve for theta. What do I have to do to get theta by itself? Minus pi. Thank you, Evan. Just take pi away from all three parts, right? We're going to take pi away, and take pi away. So here we have just theta. 2 pi minus 1 pi. 2 minus 1 is just 1. 1 pi. And 0 minus pi, negative pi. So this is our new start and stop. So the phase shift was pi units to the left. Oh, we already talked about that. And this gives you the starting and ending point of each cycle for the graph. So I'm actually going to take away all of this text and we're going to graph it. So we're going to graph this. And our graph says we're going to start at negative pi to pi. And I know that, you know what? Here, let me fix this. Alright, so we went ahead and graphed the normal sine function from 0 to 2 pi. But there was a phase shift pi units to the left. So if I take this sine function, just the sine function, I'm going to duplicate it, and I'm going to color it a different color. Oh, not green. Green's the same color as the graph. How about blue? Okay. If I take this graph and I shift it pi units to the left, then I'm going to end right there. And that's my new graph. Did you see what just happened? I took this graph, the normal sine function, and shifted it pi units to the left. So technically, I don't need to have my original sine function, but I wanted to show you this is really just shifting of that sine function. So this tells me where I start and where I stop. Okay? There was no compression, nothing happened other than just a phase shift. So now let's try some more complicated ones. Alright, so in the next example, we need to identify our A. What is our amplitude? Everybody, what's our amplitude? 1. There's just a 1 in front here. we don't know what our b is yet. We need to identify it and factor it out. So we just had a second to think about that, and a couple of people suggested divide each of these by 2, or get a 2 on top here. To get pi over 2, to have a 2, well, let's put a 2 there. Make it 2 pi. But I can't just do that on top. I have to also do it on the bottom. So multiply by 2 on top and bottom. Then I can factor out my 2 and have it 2 times theta minus, so this got removed, but this remains. So pi over 4. That's one way of doing it. Yes. All right. So we now know our b value. That can help us find our period. So 2 pi divided by my b value gives me a period of pi. So my period now is just 1 pi. But we also had a phase shift, right? We shifted pi over 4 units to the right this time. Pi over 4 units to the right. So our phase shift, pi over 4 units right. Alright, so let's do our 0 to 2 pi to figure out where do we start and where do we stop. So our 0 to 2 pi, we go 0, 2 pi, all thetas in between. That is our normal period for a cosine. But now we have something different in here. So let's look at this. From 0 to 2 pi, 2 theta minus pi over 2. Okay. Okay, so I used this right here. Okay, I used that one. I don't have to. If I've done this correctly, then I could use this one and it'd be a lot simpler. But let's say I made an error. I'm not sure if I made an error. So maybe let's try it with this and make sure that we get it, that it agrees with our other work. Okay, so this says we moved pi over 4 units to the right. So let's make sure that this agrees with that. Okay, so I put the main thing in there. And what's my first step? To get theta by itself. Goal is to get theta by itself. What do I want to do to both sides? Add pi over 2. Good. Add pi over 2. So that adds to pi over 2. Add pi over 2. It cancels that out. So I'm left with 2 theta. And if I add pi over 2 on this side, I can't add them yet until I have the same denominator. So I just need a 2 denominator. How many? So I go times 2 over 2. So I get 4 pi over 2 plus pi over 2. Did I lose anyone right there? Times 2 over 2, 4 pi. Okay, we have 5 pi over 2. All right, our next step is then to get rid of that 2 by that theta. So how do I get rid of that 2? Divide by 2. But you know what? An easier way to get rid of it is multiply by a half. Cutting something in half is the same as dividing it by 2. So really, I'm dividing by 2, but that's the same as times a half and times a half. Do you agree with that? If we divide by 2, it's the same as cutting it in half. So if I multiply this one by a half, I get pi over 4. Here we get theta. Here we get 5 pi over 4. Yes?
How'd you get 5 pi over 2?
Okay, so I had 2 whole pi, but I want to know how many halves is that. So it's almost like saying I have 2 whole pizzas, but how many half pizzas do I have? 4. So I rewrote it as 4 halves. I have 4 halves is the same as 2 whole. Okay, so I just multiplied by a form of 1, 2 over 2, to get that 4 halves.
That's just to make it easier to add.
I have to have it that way to add. Yep, exactly. Okay, so now I know that I start at pi over 4 and I stop at 5 pi over 4. Does that agree with my transformation? This said pi over 4 units to the right. Did that make sense? We moved to pi over 4. We started at 0, but now we're at pi over 4. Do we agree? It agrees. Good. So I probably did that correctly. So now we want to graph it. Alright, so we're setting up a graph over here. We want to put some tick marks. We know we need to plot 5 points on the sine and the cosine curve. So I've got my 0, 0. That's not going to be part of my curve because I need to start at pi over 4. But I'd like to start with pi and 2 pi. That's where I normally am at. And then let's cut that in half and say pi over 2. And then cut that in half and say 3 pi over 2. And then if I keep cutting in half, I'm like, well, half of pi over 2 is what? Pi over 4. And then, so now, somebody in my other class, Julia, she suggested that we count by fourths. Let's count by fourths. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, 5 pi over 4. Oh, that looks familiar. 5 pi over 4. That's important. We're going to need that. 6 pi over 4, 7 pi over 4, 8 pi over 4, but we don't even need to go that far. All we need is from pi over 4 to 5 pi over 4. So we know that we're going to start at pi over 4 and we're going to stop at 5 pi over 4. When I am talking about cosine, am I starting at 0, 0 or at 1, 0 or 0, 1? Yeah, I'm starting up at the top. So at pi over 4, I'm up here at 1. So each pi over 4 increment, I'm moving so from 1 back to 0, back to -1, back to 0, and up to +1. Here's my cosine function. From pi over 4 to 5 pi over 4. And if I think about this, there were 2 things that happened. Let's look at what our original function would have looked like. Let's make it a different color. How about neon green? Didn't make neon green. Where'd he go? Okay. So this neon green function, when we started, it would have been at 0, 0, and it would have gone from 0 to 2 pi. Sorry, it's a little off, because that should be down there where pi is. Okay, but my cosine function would have started from 0 to 2 pi. But 2 things happened. What are the 2 things that happened? Okay, so we shifted over how much? Pi over 4 units to the right. So we shifted that point pi over 4 units to the right. And we had a horizontal compression, actually, because it said times 2. Remember, when it's on the inside, we're doing the opposite. So really, we divided our period in half. So instead of our period being 2 pi, we figured out our period was 1 pi. So we're taking this and squishing it back down into half the distance that our period would have been. Yes?
Can't you do something else? Can't you just draw your standard cosine graph?
All right. This looks like a lot of words, but really it's as simple as move up or move down. Okay? I think this plus D, so we have A, B, C, and D. If D is positive, go up. If D is negative, go down. This should be sorry. We're going to talk about the midline. So if we have a sine function, and this is our sine function, our midline is right here. If normally that starts on the I'm not going to be able to undo this, huh? Normally, the sine function is going to be on the x-axis. But let's say I shifted up 2. Well then, 1, 2. It's going to be up 2. My midline moved from the origin, from the x-axis, shifts up 2. Okay? So we're going to draw a dashed line where our midline is and make our amplitude off of that. So we want to establish what is our midline equation, and notice it's just y equals d. Our d is that y equals d is our midline. Alright, so let's try one. Here we have this. Go ahead and write this down. Y equals 2 cosine theta minus 5. So, let's first identify where is our midline going to be. 2 cosine theta minus 5. Down 5. So our midline, let's go ahead and write that midline equal is line, midline is at y equals negative 5. So down at 1, 2, 3, 4, 5, this is our midline. Okay? And then we have 2 cosine theta. What does 2 do to my cosine theta when it's out in front? It changes, oh, compression. You're feeling like it's B. I think you're misinterpreting this as B. If there's a B here, that compresses horizontally. This is an amplitude, yeah. So that tells me I'm going to be going up 2 and down 2 from my midline. So we're going to draw 2 more little dashed lines to tell me how high my function's going and how low my function's going. So from the midline, my amplitude is 2 higher and 2 lower. Is everyone seeing this? We're okay with this? Yeah, there's nothing changed about my period. The period is still just 1, right? So if we factored out our B is just 1 times theta minus 5. So B didn't change at all. Period's 2 pi. All right, so I can go 0, pi, 2 pi. So 1 full cycle, this is cosine. So we're starting high. I want to make my halfway marks. It's very important that each of these tick marks is labeled. All 4 of them should be labeled. Pi over 2, 3 pi over 2. So we have 0 at pi over 2. We're back at the midline. At pi, we're down at the lowest point. At 3 pi over 2, we're at the midline again. And then at 2 pi, we're up above. So now we have this function. That is our cosine curve, but instead of it being up on the x-axis, it got shifted down 5 units. What do you think? Does this make sense? Basically, we moved down 5 and we stretched it by a factor of 2. So from the midline, we went up 2 and down 2. So we want to maybe identify these values. 1, 2, 3, negative 3, negative 5, negative 7. Alright, we're going to try one, let you guys do it together. Oops, sorry. Oh no. Alright, in order to graph sine and cosine function, to help you remember the things that you need, I switch the order of things and it makes more sense. M-A-P-P. You need to map it out. M-A-P-P. First, find your midline. Go ahead and write this down. First, find your midline. That's important. Next, find your amplitude. You need to find your period and your phase shift. And once you've found all of that, you are ready to graph. Now you need to consider, is it sine, is it cosine? Am I starting high, starting on the midline, or starting low? Why would we start low? If there was a negative out in front, there was a reflection. Good. So we need to identify all 4 of these things, and that's basically what the next slide is showing. Midline, amplitude, period, phase shift. I highlighted just the keywords, so Zach, you won't feel like you have to write everything down. You're awesome, though. Yeah, sorry. You're famous now. Alright. So basically, those are the things that you need to find. So, can everyone please identify those 4 things for this one? Find the midline, the vertical shift. What's the midline? What's the amplitude, period, and phase shift? Ready, go. Alright, so the very last one, we've just done all of these in class without your help, but check and see if you got the same thing. phase shift is now going to be, we just factored out a half, and we see that we're going to be shifting 2 pi units in which direction? To the left, because it's opposite. To the left. Okay. Whew. So we didn't do the 0 to 2 pi thing. Let's try that and see if it confirms what we are feeling about our phase shift. So I'm going to give us some more room here. We're going to do our 0. Oh, goodness. Computer's being slow. 0 to 2 pi. But instead of putting theta in here, what am I going to put? What am I putting inside that? Theta over 2 plus pi. Okay. Let's go ahead and solve this for theta, and then we'll check in. Ready, go. Try it on your own. We just figured out we're going to multiply by 2 in this case to get my theta by itself, times 2 to get rid of that, times 2, and times 2. So we end up that the place that we are plotting starts at negative 2 pi, ends at positive 2 pi, and that tells me that my period should be 4 pi, which is confirmed by what we did earlier, that our period is 4 pi. No. So if we're looking at 2 pi, if we have 2 pi's and we take away 1 pi, we have 1 pi left. Okay? All right. I believe that is pretty much... Okay, so let's go ahead and graph it. I don't have all my information, so I'm going to take a picture of my information. No, I'm not. All right, so we're going to go ahead and graph this. So we had talked about maps, right? So M-A-P-P. Well, not maps. There's no S. Midline. We want to start at our midline, and our midline is -6. So we're going to go down 1, 2, 3, 4, 5, 6. This is our midline. Maybe label it -6. Our amplitude is 4, so we're going to go up 4, 1, 2, 3, 4 to -2. We're going to go down 4, 7, 8, 9, 10. Alright, so up 4 and down 4. If we want, we could put the highest points we plot are going to be up there. The lowest points we plot are going to be down here. Alright, amplitude. Then we have our period is 4 pi, and we figured out that our phase shift tells us we start at -2 pi and we end at +2 pi. So we're going to go back here, -pi, -2 pi, 0, pi, and 2 pi. We want to get those as evenly spaced out as possible. Alright, then I think we are ready to graph. So we are graphing which function? Cosine. So at the midline, we go back to -2 pi, and we need to get one full period, one full cycle between -2 pi and 2 pi. So we need 5 points plotted. We have up, and then at 0, and then down, and then back to 0, and then up. So our cosine looks like this. Over, down, up, and over. So that would be the graph of y equals 4 cosine of theta over 2 minus pi minus 6. Alright, so we've got 4 different things happening there. We had a vertical shift, horizontal shift, actually a stretch, horizontal stretch, and a vertical stretch. Alright. And that is it. So I'm sorry that 9 people were out on that field trip today, but there is now this video for you to watch. Hopefully it helps.